So hi everybody and welcome back to the C++ tutorial series for absolute beginners. This is video 305 and in this video we are talking again about reference declaration. We stopped in our last video here with this strange function call with assignment, and now we are talking about R-value references. And again, what is an R-value reference? Something which has two ampersigns here. This is an R-value reference, for example, and let's dive into these examples here. So you can see they are creating first again an object here, and then they are trying to reference this object with a R-value reference, and that is not allowed. So because an R-value reference can only bind to temporary results, and this one is not temporary. This is object which has a storage location, and we learned L values has storage location, so we can't bind to this. Here in the next example, they are creating again an L value reference. You can see it's again an L value reference, but this time it is a const. And this const is doing what here? That's interesting because we have here S1, okay, it's an object, but here we are computing. So what we are doing is S1, this plus is overloaded. It means here with strings concatenation, which means the value test here will be concatenated. So with other words, again, added here another test is the outcome. And you can see here, we can add this here indeed to our reference, which is normally not possible. Why I say normally not possible? Because the normal L value reference requires an object, right? And this one is not an object. This S1 here is an object, yes, but this one not. Why is this not an object here? Think about, we are computing the result of this value here at this point, not here. The test is saved here in S1, but the result of S1 plus S1 is test, and it is just here. So that's why it's called temporary. But the question is now, okay, why we are binding it to an L value reference? That's normally not possible because an L value reference, we know it, need just an object here. And the answer is because we are using this const. This is a special case. And when you use const with an L value reference, then you can bind temporary values to it. And they are doing this here. And important is the lifetime of this temporary object here is extended, because this here is still just a reference. It's not an object. This is not a real object too. It is just a temporary value. So they are both know there is not a real object here, and that's why they say the lifetime is extended. Normally what happens is after this computation, this value is gone, right? Test, you would assign it to save it anywhere, and this here, this computation would be normally gone. But they with this special case, it's extended. And what they mean with extended lifetime means you can use now this reference R2 in the scope. And what means the scope? Only here where it was declared. When you go out of the local scope, in this case it's here these two braces of the function main, R2 is not usable. That means lifetime extended, and this extended lifetime means only you are declaring it here till the end. Here you can use R2 again if you want, but after this one not. So they are trying indeed using R2 here, you can see in the second one, but this one is not working. Why not? Not because the lifetime is not extended, because they are trying to modify the reference, and this one is a const. Const means still you are not allowed to modify it. All right, that makes sense. Let's go to the next example here, and now you can see we are using a reference, a R-value reference, not like here an L-value reference, an R-value reference. And again, I said before, an R-value reference can bind to temporary values. This one is a temporary value, so we can bind to it. Okay, that fits and it's perfect. And then here we are trying to modify it, like here on top. Here was not possible because it was const, and here it is possible because it is not const. And that is interesting. Why is that interesting? Because we created a temporary value and we still can modify it. And why we can modify it, again, lifetime is extended, which means we can use R3 within this scope. That means the lifetime is extended, and because the lifetime is extended, I can modify even a temporary value. That is not often, also we have never used that, but now we can use that, and we have here two versions, one where we can modify it and one where we can't modify it, and that's interesting. So this one you have to train a little bit or understand it, because that's quite powerful. And then we can go on here to the next thing, which is function overloads, and then how to call them. So first of all, what is a function overload again? Very simple. We have the same name. And if we have a function all time the same name, the compiler is distinguishing these functions depends on the parameters which they got. So you can see they need to have different parameters, and indeed they have. Here we have L-value reference. Here we have again our const L-value reference, and here we have our R-value reference. All right, so far so easy. And then we are going to call them here. First of all, we create an object I. And then we create another object, this time a const object, which indicates you should not modify this CI. Okay. And now they are calling. First of all, they start a call. You can see this is just a call here. And this fi here, we have now to figure out when we call it with I, which is called. Of course, they say it here, but let's explain why. Why is called int this L-value reference here? Because this expression here is an L value. That's why it's called an L value reference. But the question is why it's not calling the const one, and the answer is this one was not marked as const, or let's say so the intention is that this variable should be modified probably. Because if we wanted not modified, we would write here const. So we want modify it, so the compiler says, it was not marked as const, so probably should be modified. So let's use the L-value reference, which is not const. Okay, the next one you can see we have here CI. Here, this one was marked as const, so you should not modify it. And the compiler, if it has the right overload, and we have here the right overload with the L-value reference with const. With other words, it will call a function which is not trying to modify this value CI, which you put in. And then we have a free here, which was not defined because free is a PR value, which means just a temporary value, which is just thrown in. And then it is called what? You can see it. It is called the R value reference. Again, why it's called the R value reference? Because R value reference can bind to temporary value. This is a temporary value, so we can call it. And there is another question. Why is this? What advantage we have with that? Because this one can not only bind to temporary values, because actually, I mean, it binds to temporary values, but there are actually two temporary values, right? We know the PR value and the X value is also a temporary value flagged as temporary. So an X value can bind to this as well. And this has the advantage we can use later move construction, move assignment operator. But let's see what they say here as well. So you can see if you provide not a R value reference, like something like that, this one can still bind to here it says to const int, and you can, and we know this, we saw this here on top in this example. This one can bind as well to temporary values, right? That's also very nice here. And now we are discussing this part. This is difficult. Keep an eye on this. Try to understand this. So first of all, let's read this here. It says here, R value reference variables are L value when used in expression. This is not easy to understand. First of all, R value reference variables. This one is a variable. This one is a R value reference. This is just this part, careful, only this part. Are L values. Why is this an L value? because the whole thing, the whole expression is an L value because it has a name. But the expression here is an R value reference, and that confuses many people, and we will be confused in a second when you see the next example what it means. So here we are calling this x, right? We have here our function again. We are calling this x, and look what is called here. Normally you would not expect this, I mean intentionally, so without thinking much, you would not expect this one. Why not? Because many people just want to hear the return the type here. It says, it is an R value reference, and my function here has an R value. It will call this one. But no, you can see it is not called. It will be called this one here. The question is, wait a minute, that can't be, because we have here the type R value reference, and it is calling an L value reference. Why? And the answer is, again, I repeat, and that's very important that you keep this in mind. The whole thing has a name. A name is all time a L value expression, right? The whole thing is an L value expression. If you have an L value expression, the compiler will search an L value reference, because the L value can bind only to L value, and L value can't bind to an R value reference. That was like here on top. You can see we have here an R value, and we tried here to bind an L value, and by the way, this one S1 is also an L value expression, and this is not possible. And the same goes here, and that's why it's very irritating. Careful about this one. And yeah, you had this one is one of these pitfalls. And let's go to the next one, and here is again something difficult a little bit. First of all, it starts here with this std move is a special indicator. In general, std move is just a cast, and what it does is it's a static cast. It casts this x to this type here, int ampersand ampersand. But there is again a tricky thing here, and the tricky thing is, even if it's a cast, it is more like a flag. So with other words, you can see this one here has already the type int ampersand ampersand. And now I say this move is like a static cast and makes again this one. That would make no sense, right? But the point here is, again, it takes the whole thing, it takes this name here, L value expression, and it says you are no more an L value expression. You become now, you have still this type here, but you become an X value. And X value means here you are allowed to be moved. And X value means, again, temporary, because we discussed this earlier in my value categories. I hope you remember this one. And a temporary means we can call this function here will be called, because only the R value reference can bind to a temporary, right? And yeah, it's tricky. This one is also very tricky, because you think, hey, wait a minute, we have here this one. This one is like a static cast, but it is actually changing the value expression. So it is an L value. This X becomes here an X value. Tricky, but I hope you try to understand this and read a good C++ book where it is a little bit more explained. But we go on here a little bit. We are almost finished with this part. And you can see they say, after you make this move here to an X value, then you can use this in a move constructor, move assignment. So this R value reference is powerful. We will go to this move constructor anyway soon after we finish our value categories and this move assignment, and then go on with our constructors, because we are almost finished with the constructors then. And this one we have not talked about vectors now, but okay. But let's see what we have here. Here we have this one is also interesting. Here you can read, because R value reference can bind to X values, and that was actually this example here, because we changed this one to an x value, this they can refer to non-temporary object, and this one is different than this one. Why is different? Because this one is already a temporary R value reference type, but here they are talking about real objects. What I mean with that, here you can see this is not a temporary object, this is just an object, real object with the value 42. And now I said before they R values can't bind to objects. This one, it's not possible. The only way, and this is the special case with move again, you can see they use this std move again. They say I2 is an L value, we convert you to an X value, and they are doing this with this one. And now this I2 is considered from this point on an X value, and X value means a temporary value. A temporary value means we can bind it to this one. And this is also, yeah, we make later a little bit more examples, but I hope you understand this a little bit. And then this one we can skip because we have not actor. This is the same thing like here, but just with a real example. They are declaring here a vector. They're using this vector v. You can see they are translating the L value to an X value, and then v2 gets the ownership, and then they say, okay, var v can be empty now. Okay, but that's okay. I think that's enough for this video. We will continue, but not with forward reference that we skip. We will go to the last part in the next video, is the dangling reference, which is the big problem part in this. Not because it's difficult, because it makes all-time bugs. Alright, if you have any questions, see you in the next video. And like all time, have fun, good luck, and never give up.